Hi everyone. So the next two transformations we're going to talk about are rotations and dilations. So we're going to start with dilations, and we've kind of talked about these before back when we did similar figures. Really what's happening when we have dilations is that we're making two shapes that are similar. So they're the same shape, but they're different sizes. So just like we talked about before, we end up with a scale factor, which is the number that tells us how much bigger or smaller we're getting. So this is basically everything we did with similar figures, except now we're putting it on a graph. So when the figure is enlarged, that means that the scale factor is going to be greater than 1. And if it's a scale factor between 0 and 1, then the figure gets smaller. So if we know what our scale factor is, all we have to do is times our ordered pairs by it, and then we'll have our new ordered pairs for our dilations. Okay. If they were asking you what the scale factor was, how to find it, is you would take your new size divided by your original. Okay, so let's look at our examples. Before we start, I want you guys to pause and graph those points that they give you. Don't try to just copy from the screen. Make sure you look at the points because it's going to be hard to see where all of them are. So go ahead and pause and graph those 4 things. And then when you come back, we'll work on the dilations. Okay, so our first dilation told us that we were multiplying by a scale factor of 1/2. So is our figure going to grow or shrink? Good, we're going to shrink because our scale factor is less than 1. So what we need to do is to take our ordered pairs and multiply them by 1/2. So our A prime point is going to be this point multiplied by 1/2. And remember, multiplying by 1/2 is the same thing as dividing by 2. So negative 8 divided by 2 would be -4. Negative 2 divided by 2 is -2. So if we do the same thing for the other points, just divide by 2, and we get our new ordered pairs. So for 5, 5 isn't divisible by 2, so I changed it to a decimal since we're graphing. Since it's 2.5, it's going to be right in the middle of the boxes. So let's go ahead and graph those real quick. So we're at -4, -2. That's our A prime. We're at 2, -2. B prime. And then 0, 2.5. So right in the middle, C prime. So this is our shape dilated by 1/2. It's half as big now. Okay, so I want you to pause and try the next example, and when you come back, I will show you what it looks like. Okay, so when you do that, you end up with this little tiny box right in there. We got everything smaller by, there, I'm going to cut it in so you can see. So don't look at my picture because it's graphed wrong on the original. I accidentally drew an extra line. But here's the points that you get after you multiply or divide by 3. Multiply by 1/3, divide by 3. Okay, so the bottom examples are the same. This one we're multiplying by 1.5, so I would use a calculator if you can't do that without one. But it's the same idea. Okay, so go ahead and pause and try those bottom 2 examples, and we'll go over what they should look like when you come back and what their ordered pairs are. Okay, so for the example that was on the left, we multiplied it by 1.5. So it's making it 1.5 times bigger. So this is what it should look like in the end. And then for this one, we multiplied by a factor of 3. So it got a lot bigger, 3 times bigger. So this is what that one should look like. Okay, so let's get to rotations. So rotations are probably one of the hardest transformations. They have these rules, and that's what we're going to use when we're doing our notes right now is the rules, but there's another way to do it, which I'll show you guys in class tomorrow that you guys probably would like better. But to do it that other way, you have to be able to turn your paper, so if it's like just on the screen on the test, it might be kind of hard. So that's why we're going to learn the rules too. Okay, so if we turn our figure clockwise 90 degrees, then we would be changing it, or I'm sorry, counterclockwise. Counterclockwise is this way, counterclockwise is turning it that way. Okay, so we would be changing our values like this. They switch, and then that first x becomes negative. Oh, you know, that is clockwise. I don't know what I'm doing. Counterclockwise would be going around that way. After I said it, I was like, nope, that's not okay. Okay, so counterclockwise going backwards. Okay, so that would be like one turn like this. Okay, so counterclockwise 180 would be 2 turns, so it would end up being like that. And then 270 would be a third turn, so it would look like that. Okay, so if we're doing it 180, then both of the points stay where they're at, but they come the opposite sign. And 270, they switch, but this time this one becomes negative, the x one. So let's take a look at our examples. Okay, so we need to figure out what our points are, and then we'll apply those transformations. So our point A is over here at 6, 2. Which, since we started out with the same pictures, I'm just going to fill it in for all 3. I also labeled A, B, C, D, so we would know like which points we're talking about, since they weren't on there. So our point B is at 5, 5. Our point C is at 3, 5. And our point D is at 2, 1. Okay, so our first one is we're going to do a 90-degree counterclockwise rotation. So 90 degrees was when you switch them and make that first one, the new x, the old y, negative. So we'll switch them and we make that one become negative. So switch them. First one becomes negative. If it was already negative, it would become positive. I know that doesn't happen for any of these ones, but that's what would happen. So go ahead and plot those points and see what you get, what your graph looks like. So this is what we get. It turned one turn over here into the second quadrant. Okay, so let's take a look at 180. So for this one, we keep them where they're at, but they both become opposite signs. So that means we would have -6, -2, -5, -5, -5, 3, -2, 1. So everything got switched, or the signs got switched. All those are negative. So -6, -2, -5, -5, -5, -3, and -2, -1. So if we graph those points, it's going to return twice. So it ends up in the third quadrant, because 1 turn, 2 turns. Okay. Okay, so I want you to pause and try that last example, and then I will show you what it should look like when you come back. So go ahead and find those ordered pairs and draw your graph rotated 270. Okay, so this is what we get. We got all the way in quadrant 4 with 3 turns. So we switched them, their positions and their signs. Okay, so make sure you write down any questions you guys have, and we will go over them in class. I'll also show you a different way on how to do rotations without remembering all of those rules.